Bismillahirrahmanirrahim. Welcome to the Electrical Engineering channel. Today I am going to start the second lecture of the course of electromagnetic theory, and it is the second chapter of Engineering Electromagnetics textbook. The title of this chapter is Coulomb's law and electric field intensity. So first I will discuss the Coulomb's law, and Coulomb's law was derived by the French army engineer Colonel Charles Coulomb. So he performed some experiments using torsion balance to measure the force between two charges Q1 and Q2 separated by a distance r. So according to Coulomb's experiments, he observed that the electrostatic force between two static charges is proportional to the product of the magnitude of those charges, and it was inversely proportional to the square of the distance between them. And by combining these two relationships, we can say that F is proportional to Q1 Q2 over R square. By removing this proportionality, a constant must be introduced, and that constant is K. So F can be written as K Q1 Q2 over R square. Here K is equal to 1 over 4 pi epsilon, and epsilon is actually the permittivity of the medium between these two charges, and epsilon is equal to epsilon naught epsilon R. Epsilon naught is called absolute permittivity, and it is also called the permittivity of free space, and epsilon r is the relative permittivity of the medium. The value of epsilon naught is equal to 8.854 into 10 to minus 12, and it is also represented as 1 over 36 pi into 10 to minus 9 farad per meters. This is the absolute permittivity. If the medium between two charges is air, then epsilon r will be equal to 1 and epsilon will be equal to epsilon naught. For any other dielectric medium, the value of epsilon r will be greater than 1. So suppose we have two charges q1 and q2. So if we represent this point as the origin, then this position vector will be r2 and this position vector will be r1. And if we want to calculate the force exerted on charge Q2 due to Q1, the force will be termed as F2. So F2 is the force exerted on charge Q2 due to Q1, and the direction of this force will be from Q1 to Q2, and the distance or the position vector that will be used over here will be R12. So R12, the position vector will be used if we want to calculate the force on Q2. Similarly, if we want to calculate the force on Q1, we will use the position vector R21, and that force will be directed from Q2 to Q1. So here R12 will be considered, and R12 is equal to R2 minus R1, and F2 is equal to 1 over 4 pi epsilon Q1 Q2 over R12 square into A12. A12 is the unit vector. So A12 is equal to R12 vector over its magnitude, and it is equal to R2 minus R1 divided by R2 minus R1 magnitude. So if we have understood these mathematical expressions, we can easily solve some numerical examples. So this Coulomb's law is very easy and straightforward, and let's solve one example on Coulomb's law. So we have given two charges. Q1 is equal to 3 into 10 to 4 minus 4 coulomb at M, and Q2 is equal to minus 10 to minus 4 coulomb at point N, and its coordinates are 205. We have to calculate F2, which is the force on Q2 by Q1. So first evaluate the position vector R12, it is equal to R2 minus R1. Now we will calculate its magnitude, and it is equal to 3. Now F2 is equal to Q1 into Q2 over 4 pi into epsilon into R square into AR or A12. So this is 3 into 10 to minus 4 multiplied by minus 10 to minus 4. So it will become minus 3 into 10 to minus 8 divided by, so this pi will be cancelled out. 4 nines are 36, and 3 square is also equal to 9. So that 9 will be cancelled with this 9, and we will have only 10 to minus 9 over here. And this 1 by 3 will come over here, and this unit vector uh, will be equal to ax minus 2ay plus 2az divided by 3. So this is 3 and this is the other vector. So we can further simplify this expression. So this 3 will be cancelled out with this 3, and this will be equal to 10. So this is equal to minus 10 ax plus 20 ay and minus 20 az. So this is actually minus 20 az. So you can correct it by yourself. By mistake I have put a plus sign over here. Now the magnitude of this force is equal to the square of all the components, and those components will be added, and then we will take the square root. So it will be equal to 30 newtons. And similarly f1 is equal to minus f2. So if we want to calculate f1, we have to use r21 over here, and every other thing will be similar. Now I will discuss the definition of permittivity. So the permittivity can be defined as the ability of a material to store electric energy under the influence of an electric field. So this is the Coulomb's law, and that Coulomb's law is actually derived only for static charges. So this gives us the electrostatic force between two charges, and it also considers the direction of force for different polarity of the charges. So if the polarity of one charge is negative, then the final answer will also consider the polarity of either one or the two charges. So if one charge is negative, other one is positive, the force, the final force expression will be automatically in the opposite direction. So if we calculate the force using this expression, it will give us the correct polarity or correct direction of the force as suggested by the charge polarities. So that is all about our today's lecture. For watching more lectures, please subscribe to this channel. Until the next lecture, it's goodbye.